everyone, welcome to our channel Python with GecBharuch. Myself Patel Binal. In the previous video we covered assignment, identity and membership operator in detail. Now we will be focusing on operators precedence. So let's get started. What is operator precedence? Operator precedence determines the order in which different operators in expression are evaluated, which means in Python when you write an expression that includes multiple operations like addition, multiplication, division and so on, the order in which these operations are carried out is not random. Python follows specific rules to decide which operation to perform first, and this set of rules is called operator precedence. In short, it describes the order in which operations are performed. In simple words, it tells us which operations are done first and which ones come later. Operators with higher precedence are evaluated before those with lower precedence, which means each operator in Python has level of importance. Operators with higher precedence get to go first. For example, multiplication has higher precedence than addition, which means the multiplication happens before addition. If two operators have the same precedence, the expression is evaluated from left to right, which means when two operators have the same level of importance, Python needs another rule to decide which one to do first. In these cases, Python simply works from left to right, just like how we read. Let's break down the precedence of different operators with the help of table, starting with a higher precedence at the top. First, parenthesis. It has the highest precedence, meaning operation inside parentheses are performed first. It has the left to right associativity. So, if there are multiple parentheses, they are evaluated from the left to right. Next is exponentiation. This operator has the second highest precedence. It raises a number to the power of another and it has right to left associativity, which means if you have multiple exponentiation, they are evaluated from rightmost operation first. Next is unary plus, unary minus and bitwise not operator. These operators come third in precedence. They also have the right to left associativity, so they are evaluated from right to left. Next is multiplication, division, floor division and modulus. These operators are fourth in precedence and they are evaluated from left to right. Next is addition and subtraction. These operators come fifth and also have the left to right associativity. Like many others, also bitwise shift operator, bitwise AND, bitwise XOR, bitwise OR, comparison, identity and membership operators, logical AND, logical OR are evaluated from left to right. But logical NOT and walrus operator has right to left associativity. They are evaluated from right to left. Left to right associativity. In the Python, most operators have the left to right associativity. This means when multiple operators of the same precedence appear in expression, they are evaluated from left to right. For example, 10 minus 5 plus 2 is evaluated as 10 minus 5, which gives 5, and then 5 plus 2, which gives 7. Right to left associativity. The exponentiation operation is the exception that has the right to left associativity. This means when multiple exponentiation are chained, they are evaluated from right to left. For example, 2 exponentiate 3 exponentiate 2 is evaluated as 2 exponentiate in parentheses 3 exponentiate 2 is equal to 2 exponentiate 9, which gives us 512. Let's see how this works in real code. I'm going to show you some examples that use different operators so you can see how Python decides which operation to do first based on their precedence. In the first multiplication operation, 3 into 4 evaluated first because multiplication has the higher precedence than addition. It calculates 3 into 4, which equals to 12. Then it adds 2 to 12, which gives to final result 14. The result printed is 14 because multiplication operation was done before addition. In next one, Python first calculates the expression inside the parenthesis, which is 2 plus 3. It adds 2 plus 3, which equals 5. Then it multiplies the result 5 by 4, which gives us result 20. The result printed is 20 because the addition was forced to happen first due to parentheses before multiplying. Let's check out the another example. Here modulo operation evaluated first because these all operators have the same precedence, so it evaluated from left to right. The modulo operator finds the remainder when one number is divided by another. Here 15 modulo 4 calculates the remainder of 15 divided by 4, which is 3. After this step, the expression becomes 3 divide 2 float divide 3. The division operator divides one number by another and returns a floating point number. Next, 3 divide 2 is performed, which results in 1.5. Finally, 1.5 float divide 3 is performed. Since 1.5 divided by 3 is 0.5, float division rounds it down to 0.0. So result printed is 0.0. Now let's see another case. Python evaluates exponentiation from right to left. So it first calculates 3 exponentiate 2, which is 9, and then it calculates 2 exponentiate 9, which is 512. So the result is 512. Let's see another example. In this case, Python first evaluates x less than y. X is 5 and y is 10. X less than y translate to 5 less than 10, which is true. Next, y double equals to z is evaluated. Y is 10 and z is 5. So 10 double equals to 5, which is false. Finally, logical AND operator combines the result. The result of x less than y is true. The result of y double equals to z is false. The logical AND operator returns true only if both operands are true. In this case, since one operand is true and other is false, the true and false evaluated to false. When we print, it gives us result false. Now let's look at the more detailed example. Here, it evaluates the expression inside parenthesis first. So value of x is 8 and y is 4. Then x plus y becomes 12. The expression now is then it evaluates z less than 3 or x double equals to 8. Here value of z is 2. 2 less than 3, which gives us result true. Or value of x is 8. 8 double equals 8, which also gives us true. So in OR operator, if both conditions are true, then result is true. After this, it evaluates 12 left shift 1. The binary value of 12 is 1100. It's shifting this number in left by 1 bit, which gives a result 11000, which is 24 in decimal. The expression now is 24 and true. The logical OR results true, which is treated as 1 in bitwise operation. Binary value of 24 is 11000 and binary value of 1 is. Now performing bitwise AND operation between 24 and 1, which gives us result 0. So the final result is 0. Thank you for watching. I hope this video helped you to understand operators precedence. The lecture notes for this series are available in the description below. Don't forget to like, share and subscribe for more such content. Thank you.